To summarize productivity, you can usually assume that any of the energy that's input into the organism is gross productivity, and the output to the next trophic level is your net productivity. And then the difference is always respiration. And you could also include loss to decomposers. When we measure productivity, if we're measuring primary productivity, remember we're looking at the plants. The best way to do that is to look at the effects of photosynthesis. So we use a light and dark bottle technique because the dark bottle is not going to experience photosynthesis. So the only thing we're going to be able to measure in the dark bottle is respiration. Another way that we can do if we're looking at terrestrial is that we can remove dry and wet, because remember biomass is the dry weight, a patch, cover a second with dark plastic, because once again if it's in the dark the only thing that's going to be happening is respiration, not photosynthesis. Then you would leave the third patch as it is, and then you'll just compare the weight between the two to see what the amount of biomass created by photosynthesis is. Another way that you can do this is a radioisotope method using carbon-14 and its isotopes. Or if you assume the correlation between chlorophyll and the rate of photosynthesis, you can measure chlorophyll. The two that we're going to look at in class are the light and dark bottle technique and the patches. So we'll go into more detail about how these methods work. For measuring secondary productivity, that's our second trophic level, which are our primary consumers. You would weigh the amount of food that you're feeding your herbivore, and then after a time period you would measure whatever remaining foods. That gives you a count of how much they ate. You would measure the herbivore themselves to get the biomass, and you would also need to weigh the feces, so you would know what to subtract to get your productivity. So there are things that affect the productivity of an ecosystem. When we looked at our biomes, we talked about the relative productivity and how some are more productive than others. Solar radiation is a big one. You need solar radiation for photosynthesis. And you also need ideal temperatures. So those biomes that are around the equator are going to have the highest insolation, and they're going to have warm temperatures year-round. The amount of carbon dioxide also plays a role. The amount of water, the nutrients that are present, because nutrients are limiting factors for plants, the amount of herbivores that you have in an area that are eating those plants. So the least productive ecosystems are those that aren't going to have the warm temperatures. They're going to have the lowest amount of insulation, not a lot of water, not a lot of nutrients. So those are our deserts, our tundras. Our most productive are going to have higher temperatures, a lot of water, light, and nutrients. So our tropical areas. Our forests also have lots of water, so they're able to support the growth of the trees. They're going to be more productive than, say, our grasslands. Now, as far as oceans, temperature is the opposite. It's the cooler temperatures where you have the upwelling of the nutrients from the ocean floor. The more nutrients you have, the more plant growth you can have, the more photosynthesis. So when we compare biomes, this one also has some of our aquatic biomes, like our estuaries, swamps. We can see how they compare. So those that are in the tropical areas, and then our forests are at the top. Then we have our grasslands, and then here at the bottom we've got open ocean, tundra, deserts.